this is my submission for video 3 for mechanics dynamics. The question I wrote up was, given that you're driving a 3,700-pound car down a 25-degree inclined road as shown in the diagram at a speed of 40 feet per second, suddenly you need to stop to slam on the brakes, causing the car's wheels to lock up. The road surface has a coefficient of kinetic friction 0.6, and we want to determine how far the car will skid on the road before it comes to a stop. So the distance that the car skids before it comes to a stop. The key concept that we work on this question include the work done by forces, which in this situation will be the work done by the frictional force as it goes against the motion of the car and reduces the kinetic energy because the car has to slow down and come to a stop. Also, we have to work on kinetic energy because the car is in motion at start, and also the work energy principle, which is basically initial kinetic energy plus the work done in this situation by friction equals the final kinetic energy. But in this situation, so the car has to come to a stop, the final kinetic energy will be 0. Another concept that was not mentioned in this PowerPoint, but we also work on, is the work done by forces. Yeah. Relevant equations that we need to solve this problem would include T equals 1 over 2 mv squared, which is the formula for finding the kinetic energy. Also, work done by friction is equals frictional force times the d, which is the distance that we're trying to find in this situation. And frictional force, which we use to find the work by friction, is found by the coefficient of kinetic friction times the normal force. And the normal force in this situation will be found by having forces going in whatever direction. And normal force on an inclined plane usually would be N equals W cosine theta. And finally, we have friction force times the distance, which is practically the work done by friction, is equals 1 over 2 mv squared to find D. Thank you.